Good morning, ladies and gentlemen. A heartwarming welcome to everyone who has joined us from LinkedIn Live today. My name is Judy Wu, and I have the honor today to be the moderator for the live streaming session today. As more and more people are aware of the urgent need to reduce carbon emissions to tackle the climate change, we can see more EV cars on the street. According to the current research, the sales of EV cars has actually doubled already in 2021. Of course, with this, charging infrastructure needs to support this boom as well, especially considering the current EV crisis that's ongoing. So the big question now is, where and how can we get all the electricity? Today, we're live at Cottbus, Germany to show you the possible answer to this question, a system that's developed from BTU together with Delta called Smart Grid. Joining me today on this live streaming is Professor Schwarz from BTU and Mr. Sebastian Utzig from Delta to share with you more insights on this topic. Welcome, gentlemen, and thank you very much for joining me today at this live session. So perhaps let's start off with a definition. Professor Schwarz, what exactly is a smart grid and how can it compare to a non-smart grid?
If you take the non-smart grid, which is the conventional power supply, it's relatively easy to explain. So we have very, very large power stations based on nuclear, on coal, and gas. These units are connected to the high voltage or extra high voltage system and will be operated by centralized control centers. So if you go to the smart grid, you have much, much smaller units. They are normally connected to the low voltage system or maximum to the medium voltage system. And you have thousands or millions of them somewhere in the grid, and you have to integrate that into the conventional system so that the smart grids and the conventional systems can operate together.
I have one more thing that I'm curious of. We mentioned about the EV boom, but I'm still curious, what exactly is the impact that this EV boom will make? Sebastian, can you maybe share with us this answer?
Yeah, of course, Judy. So, yeah, absolutely right. The increase of EV cars in the market will definitely have an influence on the grid. It means we will see more peak demands in the grid. We will see more stressed out energy grids in the end. And therefore, we will also potentially have customers looking into penalty situations where the energy companies are asking for higher charges, etc., etc. And therefore, we need to find solutions. Nowadays, we have solutions like energy storage already available to keep the system, the grid system, more stable and active.
So this is, of course, the impact that we have to take into consideration. Professor Schwarz, coming back to the topic of smart grid, as part of the electricity infrastructure, what does this have to offer in response to the energy crisis?
I think the main problem or the main task actually is that in Germany we want to move out of nuclear and out of coal nearly at the same time. So that means we only want to base our power supply on gas-fired units and on renewables, mainly based from wind and from photovoltaics. And now suddenly we have a situation that we have a very fluctuating source from wind and photovoltaic, and we are looking for, let's say, flexible loads, which can be adjusted according to the needs of the grid, and on storages. So one idea, maybe not today, but maybe in some years, is that we can use e-cars as flexible loads, so charge them according to the needs of the grid, and use the batteries of these cars as a large distributed storage in the system.
This indeed sounds like a very interesting concept, also in response to the current energy crisis and also the government policy as well. Of course, to invest in this transition is not a one-day work. With this in mind, what exactly has been installed in BTU as a proof of concept?
I think, let's say, to work on smart grid. So smart grid itself is not a new idea. So a lot of millions of researchers around the world work on this topic. The main problem is always if you have new technology to scale it up from the laboratory at universities or at research centers to the real life. And if you tell real figures, for example, if you go to a university lab, the apparatus there is in the range of 1 kilowatt, 2 kilowatts in this size. In the reality, you need 1 gigawatt or 2 gigawatts or 20 gigawatts. So that means in minimum factor 1 million in between. And you can't scale it up in one step from kilowatt to gigawatt, so that never will work. So you have to do that in several steps, and normally one step is only factor 30 to 50. So that means we have to go from 1 or 2 kilowatt to 50 to 100 kilowatt. That's what we built up here. So we had a smart grid now in the range of this 100 kilowatt, consisting on photovoltaic, battery storages, power to heat, power to cool, power to vehicle. We also have a combined cycle unit, and we have also e-cars as flexible loads and also as storage, so it means at vehicle-to-grid systems.
Sebastian, I know that Delta is part of this proof of concept as well. What exactly has Delta been involved in this project?
Well, yeah, we're absolutely happy to be a member of that project. So we installed here or delivered to that project 4 ultra-fast chargers, our flagship DC fast charger with up to 200 kilowatt of charging power. And like the core system, to have a proof of concept for vehicle-to-X, we installed 3 vehicle-to-X chargers directly here at the location.
Perhaps I'm more interested to know what exactly are the milestones that we have achieved. Professor Schwarz, can you share with us what exactly has been achieved so far?
I think important for this upscaling is not only the factor on the, let's say, installed capacity, it's also the connection to the industry. So you need suppliers or manufacturers of this technology. So that means in this specific case, we looked for a manufacturer for chargers, and we found Delta. And we also looked for, let's say, a supplier or manufacturer of e-cars. So both you need to make such a project. And if you have this cooperation, then, for example, you have to, and that was one of our project parts, we have to develop an energy management system to connect the charger via the back end to the grid control center. That means to our smart grid control center, simply that we can exchange the information on the needs of the grid. And the second part is we have to integrate the driver or the owner of the car, because the idea of such a car is not staying at the charger as flexible load or as storage, because the owner wants to use it for driving. That means you need a communication between the driver and the back end. For example, where the driver can type in, now it's 8 o'clock in the morning, I plug in this car to the charger, I want to have it back at 4 o'clock in the afternoon, and then, for example, it must be fully charged or 70% charged or whatever. So then the grid control center and also the backend know we can use this car as, for example, a flexible load or as a storage within the next 8 hours. So that was the part we developed together with Delta in this project for about 2 years.
Can you share with us perhaps how many charging points has been installed throughout the campus?
That is a good question, because we worked on this vehicle-to-grid system since, 2010. So we started with 15 chargers. That means own design made from BTU. Then we moved into that project with Delta. So we had several of these ultra-fast chargers here on the campus and also on some other places in Cottbus. So in total, I think we run actually 35 to 40 of these charging points within the university, which can be used from our employees, or, for example, can be used for the charging of business cars, so BTU-owned business cars. Normally not for, let's say, the use of external persons, because that is, from the legal point of view, it's a bit too complicated if universities sell energy to external persons.
Do you see this as a common practice for universities, or BTU is actually one of the leading position in this?
I think that's the question: who will start how early and can organize how much money? So that means we started, I told you, in 2010 and now reached this 37. I think if you make a ranking of German universities, I think for sure we are number one. I think second place will have, I'm not really sure, 15 to 20 chargers, and then it will go down to 1 or 2 or 3. So that means, let's say, that's for universities, it's really complicated to organize the money and to do the work on that part.
But of course, to reach to this point where BTU is at now, I believe it was a long process, and there would be a lot of difficulties that you have faced in between. Perhaps, Professor, if you can share with us a few of the difficulties you have encountered throughout the process?
I think the main problem during the whole time, so starting from 2010, Main problem always was how to get the car, or from where to get the car, the e-car, because you know, if you want to communicate between the charger and the car, you need a car who is willing to accept this communication. The main problem is if you take the, let's say, standardized system, so you have this CHAdeMO standard in Japan, you have CCS standard in Europe, you have an American standard, you have Chinese standard, so that means the car decides if it will communicate with the charger or not. And so in our project together with Delta, we focused on CHAdeMO standard from Japan, so we used Nissan cars, and that's what we did in this project.
From Delta's perspective, as we're also part of the project, what are the difficulties, Sebastian, we have faced throughout this project?
So basically what we provided here for the bidirectional charging is this 3 vehicle-to-X chargers. Back then, based on, let's say, a pre-series product line, and we of course had to develop it further into that ecosystem Professor Schwarz just described, from the back end to the user, back to the back end, and then to the grid side, actually, to fulfill all that activities. And therefore we had to improve the hardware, but also improve or actually develop the software back-end system depending on the requirements from the BTU and the local smart grid here.
It seems like this smart grid certainly can offer, like, as one of the solutions to tackle the energy crisis and also with the EV boom. But aside from the smart grid concept, are there any other methods that we can do for grid management, Sebastian?
Yeah, of course. We do have solutions available in our portfolio, let's say to the outer world, to the real world we're facing right now with customers already seeing today increasing energy or power demands, etc. So therefore we already provide or offer software energy management solutions and also energy storage solutions together with our EV charging equipment.
Looking beyond this project, what is the next step for the Smart Campus, Professor Schwarz?
I think the next step is very in line with this upscaling factor I just told you before. Because actually I told you we have 100 kilowatt size, so that is a pure smart grid for research. We can do everything in that smart grid. We also can make failures. Next step is to go into the megawatt level so that you come closer to supply, for example, a supply structure of a city. So that means idea is we want to use the whole BTU campus because we have an independent 20 kilovolt supply structure. We have a peak load of 2.5 to 3 megawatts, which is also, again, factor 30 above that one which we actually have. So idea is to convert the whole campus into a smart grid with a huge amount of photovoltaic, so 3 megawatt, a lot of storages, flexible loads, not only e-cars, but also other ones, also vehicle-to-grid structure, so that we have distributed e-car storages. Main problem is that this structure then has to supply the campus. It's not a research structure, it's a supply structure. That means whenever you make any failure, the rest of the university will recognize that because you will lose the supply in that system. So that makes it much, much more complicated, also more expensive. Actually, we had a nice description of what we want to do. We're just applying for the money we need for that system. Hopefully in, let's say, summer next year, we have that money, and then possibly we can start moving in this next upscaling step.
As we talk about the future, I would like to ask both of you, what is the future going to be like in response to the energy crisis and the rise of EVs from your perspective? Perhaps Professor Schwarz, your view on this?
Yeah, I think one of the main tasks from our government, meanwhile, is to look for storages, any type of storages, concentrated batteries, vehicle-to-grid, so e-car battery systems, other types of storages. And they also published, for example, an announcement that you can apply for funding if you want to go for vehicle-to-grid fleet management, so more cars at one place. So we also applied for this program. And if we are so successful, then possibly we can start a next step together with Delta, that we move into vehicle to grid, but now based on CCS standard.
Thank you, Professor Schwarz, for sharing your view. Sebastian, your view to the future?
I think in regards to energy crisis or climate change, the measures for both are more or less the same. Means we need to move, as Professor Schwarz explained, even faster towards flexible energy grids, including more renewable energy, storage, etc. And therefore, we also need to think more flexible ourselves how to integrate cars, EV cars into the grid and make business cases and applications out of that. So we are absolutely keen on that. I heard also that we are already working also on a CCS solution for the vehicle-to-X charging. So from that perspective, I'm really positive and looking forward to continue our collaboration.
Thank you very much for sharing your view and with all the inputs on these topics. We have talked a lot about the smart grid and how this can be a response to the EV boom and the energy crisis. And we look forward to see how this will be able to be developed in the future. Once again, thank you, Professor Schwarz, and thank you, Sebastian, for your fascinating discussion. Thank you once again for joining with us today. We wish you a very nice day and goodbye.